As I was saying, this will be on your formula sheet tomorrow. Y2 minus Y1 over X2 minus X1. And we just plug these points in. Where this problem gets people and why it's on that benchmark to begin with is because of all the negative signs flying around. You can expect those tomorrow. Y2 is negative 16. You type it in exactly as it is. Minus symbol. Always minus symbol, no matter what the Y1 is. In this case, the Y1 is negative 9. So look, mine looks goofy, but your calculator is going to fix that for you because that should actually just be a single plus sign. Next, we have X2, which is negative 19, minus X1, which is negative 3. Bunch of negative signs flying around, but it comes out to be a nice, neat 7, 6. I guess that's not really nice or neat, but either way. Number 11, okay? This is in standard form. In standard form, there is a way that we can find slope, okay? The shortcut here is just to know that it is negative a over b. In other words, this would be 7 over negative 4 and then a negative sign out front. Well, those are going to cancel out to be 7/4, okay? But a lot of people aren't going to remember that little shortcut, and that's okay because we can do this just by our equation manipulation. We don't know slope from standard form, and if you don't remember that little formula, and it's not on your formula sheet, you have to memorize that. But we know how to go from standard form to slope-intercept. And slope-intercept has the slope right there for us. So if we can get y all by itself from this equation, if we can get y all the way by itself, we'll be able to just look at our equation and find our slope. 7x minus 4y equals 20. I'm going to subtract 7x from both sides. Now, I'm going to write my negative 7x first, and then my plus 20, or 12 if I'm just writing random numbers down, because that's how it's going to look in my final form, okay? Next, I divide by negative 4 on both sides, or divide everything by negative 4, whichever way you want to say it. Negative 7 over negative 4, negative times negative, or negative over negative is a positive 7/4. And then we have minus 5. Minus 5 doesn't really matter in this case. What we were after was that slope of 7/4. Hard problem there, okay? Number 20. Sorry, I had the answers from last block already up there. Number 20, or number 12. Golly, I'm confusing 12 and 20 today. Tough day. Write the slope-intercept form of the equation of each line. So you look on your formula sheet, you see that slope-intercept is y equals mx plus b. I need two things here. I need a slope and I need an intercept. From this graph alone, you can find those without actually doing any math, okay? Our intercept is clearly down here at 0, negative 5. But that's also a point on the graph, okay? That pretty much leaves us down to two options. Because this has a negative 5 and this has a negative 5 for our intercept. From here, all we have to do is just find the slope. For the slope, however, we're going to need 2 points on the graph. And I can see another one right there. Okay? Well, if I rise positive 2, and I run 1, 2, 3, positive 3, that means my slope is simply a positive 2/3, meaning my answer has to be D, because this would be y equals 2/3 x, because that's my slope, minus 5, because I had a 0, negative 5 y-intercept, okay? Also, you could have noticed that this had a negative slope, and this had a negative slope, and we know that this line is increasing. That could have eliminated those, so basically there was a way to eliminate all 4 of the options. You could have gotten this down to a 50-50 if you only knew how to do slope or if you only knew how to do y-intercept. You could still get this down to a 50-50. 13, is the following a function? This is just asking about the vertical line test, which means when we draw a vertical line through our graph, we should only ever hit it one time, okay? You never want to hit it twice. So yes, this is a function, but there's 2 answers that say yes. We have never used anything called a horizontal line test. Never. We have only used the vertical line test. So don't get confused with that tomorrow, please. Don't get confused. Number 14, sketch the graph of each line. Right here, we're given equations, and we want to see if our graphs look the same. Guys, we cannot graph from standard form. We graph from slope-intercept, which is y equals mx plus b. So when I've got this equation, x minus y equals 4. Again, our key thing with slope-intercept is this y being by itself. So we want y by itself. Subtract x from both sides. We have negative y. Guys, 4 and a negative x, that's oil and water. They're not going to mix, okay? We have negative x plus 4. I write them in this order because that's the order it's supposed to be in for our form. We're not done here, and this is where people will mess this up, okay? People will mess this up all the time because I'm going to make sure there's an answer on there that looks like this. Because especially here it is right there with A. If you stop right here, you're saying you have an intercept of 4 and a negative slope of 1. That's what this graph is. But we're not done there because we still have a negative sign in front of y. When we divide both sides by negative 1, it flips our signs. So we actually want a slope intercept, or an intercept of 0, negative 4. And we want a slope of 1, which is 1 over 1. So we're looking for something that starts down at negative 4, crosses at negative 4, and goes up 1 over 1. Well, B starts down at negative 4, but so does D. Well, our slope is positive 1, so you should have B. Number 15 is kind of a trick problem here on the review. A lot of people are going to go right into their calculator immediately and just try to graph this. They're going to say, oh, y equals 3. And they're going to graph it, and they're going to see that horizontal line. They're going to think, oh, yeah, there we go. There's my answer. Easy peasy. Done with that one. This is not y. This is x equals 3. Y equals a number is a horizontal line. X equals a number is the opposite. It's a vertical line. And particularly, this is a vertical line at positive 3. Well, there's a vertical line, but this is at negative 3. This line's just doing all kinds of weird stuff. We're not even anywhere close to that. D has to be our answer. Number 16 goes back to the vertical line test, okay? And that's really what it is, but it's asking you this with points, all right? Think about what makes something pass or fail the vertical line test. We saw a graph earlier that passed it. That means every line I drew through it vertically only hit once, okay? What fails the vertical line test is something like that, where it hits twice. Well, what would those 2 points have in common? They would have the same x value. For example, this might be negative 2, 2, where this is negative 2, negative 3. Point is, they have the same x value. So if you have repeating x values, okay, that means we are not a function. Repeating x values means not a function. 1, 0, 7, negative 2, another 1. Okay? So this is not a function. Well, that gets rid of A and B. So no and no, there's an ordered pair that is the reverse of another. There are x's that are not unique. That means repeating. So D. Okay? We haven't ever talked about ordered pairs being reverses of each other. It's a completely different topic. 16, not a function. Remember, this is just the review, so it's not like you can just say, oh, that means the one tomorrow is going to be not a function. I don't remember what the one tomorrow is. Okay? Be prepared for both of those. 17. This problem most people will get. This is the way we like to do these. We like to be given the domain, which means x value. So we just take that negative 2 and plug it in. 5 times negative 2 minus 4, that's negative 10 minus 4, which is negative 14. That's the way we like to do this, okay? Alternatively, if you just want to graph it and look at the table, 5x minus 4, enter. We can graph it, sure, if we want, but we really want to look at the table. We want to know when the x is negative 2, what our y is. Well, there you are, negative 2, negative 14. Didn't even have to move for it. Number 18 is the exact opposite. It's going to ask for the range.